Hello everyone, welcome back. Hope you had a very eventful break, and now we'll be moving on with the part two of today's MLFest21. So let's go on, and wasting any more time, I'll be presenting my screen now. So, okay, share. So hopefully you are able to see my screen in a bit. Yep, okay, so it should be visible. So till now, what have we learned? So till now, what have we done? We have used our, we used our CNN to work on do some classification on some classification type data. We've worked on some regression type data using our ANNs, but still there's one type of data that we haven't worked on yet. So can you guys tell me what am I talking about? Which type of data am I talking about? Let me know in the chat box. So yeah, it is the sequential data. So what do I mean by sequential data? The sequential data is nothing but a data that follows some sort of sequence or has some sort of trend in it or has some sort of follows some sort of order basically. So, but for most importantly, what it means for us data scientists or ML enthusiasts is that it is the type of data in which one entry in that data is related to the data that came before it. So what do I mean by that? We'll look at in a bit more detail in a bit. So before going deeper into that, let's look at some examples of the sequential data that we could have. So one example is the time series data, which can be thought of like the sales series, sales data. So, let's take a product like XYZ. So the sales of XYZ over, these months, like you have a few months, and every month you recorded the sales for these data, and then you put that into a data frame, and that could be considered as a time series data. So it could be the data of the sales. So we'll like go into a bit deeper into this in the next slide. And also another example of a sequence is sentences, which is a very good example, as the words which we use in the sentence are in a specific order. So if I just was to say that hello Varun is name my, you won't understand anything. But if I was to say hello, my name is Varun, you would say hello back to me because that sentence actually makes sense. And similarly, another more examples or sequences are audios, trajectories, as well as music. So let's go a bit deeper into this example. So let's go look at time series data. So like I said, time series data represents something like could be a sales chart. So over here you can see that I've taken a very interesting example of time series. So over here you can see that it's the beer, wine, and alcohol sales over the years. So basically what this data is basically the sales of monthly sales of these. So for every point in this data set is the amount of these products sold in millions of dollars. On the y-axis you can see sales in millions of dollars, and for every month there's a point on this data set. So what we try to do with this is that basically we'll be looking at this. So by looking at this, maybe the trend like which I was talking about is not blatantly obvious. If you go a little bit deeper, like for example if you look at this, so there is some trends that are somewhat obvious that this is gradually increasing as the years go by. But there are some more finer details that we can pick up if we look a bit deeper. So if we look at the first year over here from 1992 to 1993, you can see that there's this like little spike at the end of the year. So if you think about it, it actually makes sense why as to why there is a spike at the end of the year. As the end of the year marks like these celebrations, the New Year parties, Christmas and whatnot. I don't know about Christmas too much, but yeah, New Year parties, and what people like to do at these parties is consume these products. So, so like that bump in the in the yearly data makes sense. When it comes to the other bumps, I really can't give you much information about it because personally I don't contribute towards this data too much because first of all I am not old enough, and second of all this is the data set of the United States and I'm from India. Okay, moving on. So so what we'll be trying to do with this data is by we'll be training a model to pick up the trend that we saw. Like we knew that there was this spike at the end because we knew about the holidays and the year ends, New Year's. But our model doesn't know anything about that. It doesn't know anything about the New Year parties and all that. which is kind of sad if you think about it. But yeah, so we'll have to train our model to pick up on these trends, and based on that trends, maybe we'll be able to make some sort of prediction. Like you see over here with this orange line, we were able to predict something in the future. So that's exactly what we'll be trying to do with the time series data. Another sequence type I just said was the word sequences. So over here we have four words which form a sentence, which this sentence makes complete sense. It's completely fine if you just use this as this. But just in case if you did have to predict a word that came after this, what would you predict? So if you were like me, you would predict something like "Hello, how are you today?" which is another completely fine sentence. But how are we able to predict this? Is because we have been living in this human world for long enough time to know how to form sentences, how to act with people, how to talk to people. So we know that today is a good enough sentence. Hello, how are you today? Is a good enough sentence to ask someone if you want to know how they are. But our model does not have any idea about that. So how will our model know? How are we able to know that today would be the next one in this sequence? So to understand that, let's look at a simpler sequence. So the way we do that, of course, is by using the recurrent neural networks. So that's the big name. That's what you have been hearing everywhere. So why do we use these recurrent neural networks? So just like we saw our our convolutional neural networks, they're better at picking out features from your 2D image data. Like it was able to pick out the eyes of a person, or the nose of a person, or the nose of a dog or a cat, or whatever you are training it on. Similarly, so like the CNN is better to use on 2D image data. Similarly, RNN is better to use on sequential data. So, uh, why is the easy question to answer? Because why can be answered by like why not? But see how will we be using this, RNNs or our sequence data. So, like I said, let's imagine a simpler sequence instead of those words that we saw. Let's see a simpler sequence. So 1, 2, 3, 4, 5, 6. I hope it's a sequence you're all familiar with. You've been seeing it literally your entire life. These are normal numbers. So so I'll be asking you a question now. Would you be able to predict a similar sequence shifted one time step into the future? Whoa. Wait up. I said a lot of words which you probably couldn't understand. So the words like predict a sequence and one time step. What is a time step? What do you mean by future? What do you mean by shifted into the future? So we'll be going into that, but let's just to make this interactive. Let me know what would you predict to be the next number in the sequence. So 7, right? 7 is a very acceptable answer because you can see that the previous part of the sequence is 1, 2, 3, 4, 5, 6, and then the next should be 7. So how did we come to that? How did we come to that conclusion? How do we know that 7 should be the next one in this? Which is correct, by the way. 7 should be the next one in this. But if we were just given the number 6 and asked to predict something that came after it, would you be able to do it? I mean, of course, you'd be able to do it because after 6 comes 7. We know that. But let's say our sequence actually was like 0, 2, 4, 6, 8, 10. Then if we were given 6, like if there was there was difference of 2 between the inputs, then if you were given 6 and if you predicted 7, that would be wrong. So but there is no way for us to know what came before this, right? If we were just given 6. But if we were given the entire sequence that came before it, we were easily able to predict it. The next one in this case would be 7. And if I was talking about the other number case, it would be 8. So that's what I mean by having sequential data and how any entry in this data is to be dependent on the previous data. So similarly, we have to give our model, our network, a sense of the history that came before it. So now let's talk about time steps. What do time steps mean? So to maintain our sequence in the model, we need to make sure that we don't pass in the data as a like mix it together and then pass it. We need to pass it in one by one in steps. So think of time steps as nothing but just normal steps, and those steps are related to the input. So let's say in this case itself, we have 6 steps, 6 inputs. So when we input 1 into our model, it would be 1 step. When we input 2 into our model, it would be second step. So after the 6th step, or in this case, time step, we're asking you to predict the next one. And a sequence which would be a time step in the future would look something like this. So that would just be one added to everything, and then the next step. That's what the next sequence would be like, one time step into the future. But don't get too confused by the word time step, just mean that it's a step, and time is just to give you a sense of progression in the forward direction. So how do we do this? So we need to, like I said, like if you have to predict this, how do we get this 7 is by knowing about this 1, 2, 3, 4, 5. So we have to do the same thing with our neuron or our model, that we have to give it. We don't need to let it know that after 6, if you see a 6, then the next should be 7. We don't need to tell it like that. We need to let it know that there was 1, 2, 3, 4, 5 before this 6, and therefore after 6 there will be 7. So it will be able to pick up on this, trend that's happening. So how do we let our neuron know about its previous history of inputs? So one easy way to do that is to feed its output, which we got in the previous step. So for example, when you passed in 1, you got some output. So whatever output you got, you pass it in again into the same neuron along with this number 2 as an input. So I know this sounds very complicated and you have no idea what I just said. So the way, I don't worry, I assure you by the end of this, you will be able to understand everything. So the way we do this is by using something called a recurrent neuron. So our normal neuron is too stupid to handle all this. So we'll be using a recurrent neuron. So on the left you have seen this neuron multiple times. Okay, you have seen this some iteration of this for these past 2 days, this day and yesterday. But on the right here, we have a recurrent neuron. So the only difference between our actual normal neuron and the recurrent neuron is this arrow right here. So it's of course more than just an arrow, and it has a lot more going on behind it. And we'll be looking at what that does in the next part. So, okay.